Good morning everyone. Welcome back to this course. My name is Prabhu Ramachandran and I think most of you have seen me on the first day of the course. And today I will be teaching you about version control. It looks like the whole day is available for version control, but we may not want to spend the entire day on version control. So I may change a few things. So in case we finish version control to satisfaction today, I may actually start off on a little bit of basic Python today itself. And then tomorrow you will have LaTeX, and next week again you will have Python as per the schedule so far. So let's see how things go today, and then we will decide how we proceed. So anyway, good morning to you all. Thank you for joining us this weekend. Yet another weekend, a long string of weekends you have. So today's topic, as you have seen, is version control. I will try to make sure that I teach you some of the theory, and then I will show you live examples of trying to use some examples of version control. And I will expect that you also follow suit. That is, after I do an example, I will give you a few minutes that you should experiment, play around, and be comfortable with creating a repository and things like that. I think it's a good idea. If you have any questions, I will pause. Once I do an example or something like that, I will pause at that time, ask specifically for questions. At that point, you can ask me questions. If you have any problems in between, you can contact on the chat. It will be monitored, and if there are any questions that you need attention, maybe you can say, attention, we are not able to hear you, or something like that, so that I can stop and I get signaled appropriately. So today, as I said, we look at version control. We are going to use a particular tool called Mercurial. Hg is short for Mercurial, as you would imagine. Hg is the symbol for Mercury, and Mercurial is the name of the tool that we will be using in order to do version control. So if you see the slides now, the outline of this session is basically, we will have an introduction on version control itself, motivate the need for a version control system, and basically give you an idea of why we need to do version control and some idea of how it actually works without getting into the nitty-gritty details, just the overall perspective of how it works with an analogy. And then we will start with creating an actual repository and getting our hands dirty with creating a version control repository, seeding it with some files, learning the actual workflow. How do you actually use a version control system effectively? This is very important. As with anything that you have, a tool is only a tool. So even if you have a chisel or a hammer, it's only as good as how you use it. So it is important that you be able to use these tools well. Therefore, you should understand the workflow. The question is, you have tools, and it's important that you know how to use the tools effectively, and that is the crucial part. There are millions of tools. What you need to know is how to use them effectively. So we will teach you some aspects of that and kind of go through some exercises on how best to do these things. An important aspect of much of open source software is that there is a lot of collaboration. And it makes a big difference when you can actually collaborate with other people on your source code. These version control tools that we will be teaching you today allow for very easy sharing of code. Okay. So we will teach you the basic aspects of collaborating with Mercurial. Okay. And then conclude with a summary. So the objectives of the session are that first you will understand what version control is and why you need it. You will learn how to create and use repositories on a daily basis, how to clone existing repositories. So clone is exactly what it means. It is a clone. So if I clone myself, you would imagine another Prabhu next to me. The same way, if you clone a repository, you get the entire repository. And how to do this from the web. We will see how you can view the history of a repository, and you will learn how to make changes to a repository and commit them. Commit is an important technical term that is used in version control systems. And finally, you will learn how to work collaboratively as a team. And needless to say, how well you are able to do all of this depends on how much you practice. And what we will try to do is we will try to insist that in future, as you do things, that you use a version control repository in order to do all of your assignments and things like that. So let's begin with an introduction of what is version control. So think of it as a very simple, in a simple way. Essentially what a version control system does is, it allows you and gives you a system with which you can keep track, important word is track, of changes that are made to files over time. Okay. So basically the keywords are track changes made to files over time. So as you evolve your code base or your document or whatever it is that you have, it will keep track of what the changes are. And it will internally keep copies. And the details of how it keeps copies is not of any relevance to us right now. What is important is that it keeps some reference or copy of all of this information. And usually version control is best used with text. Okay. Things that have a notion of a difference. If you have just a binary chunk of data, it's very difficult to actually produce something that shows an incremental change. So if you have an image, you don't have an incremental change to an image. You can usually change the image completely, typically. So the notion of version control is best applied to things like text files and documents which are not binary. So if you use LaTeX, which you will be learning soon, you can see that you can use all your LaTeX sources can be put into a version control. You can also use binary files and version control binary files as well. But the way in which a binary file behaves is sufficiently different that binary files are treated differently. Okay, they are not the same as a text file. But regardless, the version control tool will allow you to keep track. So every time I check in a new version of any file, I will be able to go back in time and retrieve the old version if I want. Okay. So if I were to use my own homegrown solution to do this, how would I do it? Well, we all have done it. Many times when we write our own projects, or if you look at any student's project, typically they will have one directory saying my project, and inside that my project they will have a in this case you have an a.out, id1.txt, id2.txt, pda1.cpp, pda2.cpp, pda2.1.cpp. So basically the user, every time they make a significant change, will copy the file, change the name slightly and do it. And what a mess. So imagine if you have a file, if you have a project which has 100 files. If you change every file like this for every version, it's going to be some 300 files. Already 100 files is difficult to manage. The idea is the tool that we build will make it a lot easier for you to cognitively manage all of this. So you don't have to deal with 100 files, which revision, what date. For example, in this case, I have pda1.cpp and I have pda2.cpp. How do I know which I modified? How do I know when I modified it? How do I know which other files this pda1? So supposing I have pda1 and I have some gda1. Do I keep track? Is gda1 linked to pda1? The idea is I want to be able to build the same project which has interdependent links, for example, at another point in time. I can't do it because I don't know if these files together fit as one or each is in its own independent universe, right? I may have made pda1, pda2 and gda1, for example, and gda2. But gda2 may only work with pda2, but gda1 may work with both. You don't know all of these things. So if you have a version control system, it manages all of this for you and makes it very clean. So again, let's recapping the issues. Name and changes made are not related or linked. So any changes you make to a file are not linked. You don't know what is the connection between one link. Are they all at the same time? Are they at different times? There is no time information. Similarly, I can't quite track the sequence of changes unless I impose a convention saying 1, 2, 3, 4, 5. The connection is 1, 2, 3, 4, 5. Right? However, I may have made change PDA1, then made GDA1, and then made PDA2, which means it flows in a different way, right? PDA1, go back. I first change PDA1, then I change some ID2, and then I come to PDA2. That is one way. Or it could be PDA1, PDA2, and then ID2. None of this information is actually tracked. The other issue is obvious that it doesn't scale. As I said, if you have 100 files, it's not possible to manage this. So, given all this, version control allows you to do the following. You can track the entire history and evolution of a project. So, if you look at many open source projects, they'll even have a web interface where you can go on the web, check that project and see what happened at this time, what was the situation of the repository, and you can actually fetch the entire source code 1 month back, which is very convenient. Because I can now track the history and evolution of a project, it allows us to collaborate effectively. Why? Because if I am developing, say, the same source code, I don't have to necessarily be in sync with you every single day. Supposing I say, this is my version, I am now building all my changes with respect to a version 1 month from before today, and you are working on the code today, then both of us know with reference to what are both of us working. So it's easy for us to collaborate. I now know, oh, this change only applies to the file at that time. I can now look at my file and say, oh, this is the actual change he's made, and now add this. Instead, if I didn't have this information, I would have no way of figuring out what exactly the changes are, unless I looked at every single file this way. And the tool also typically provides a lot of other additional functionality that lets you collaborate very effectively. It allows you to merge, it allows different people to clone. So it becomes, instead of having me to make tarballs every time, if I just give a URL, someone is able to make a copy of my entire repository immediately. Another major advantage is, very often, so you may have seen Firefox, I think the latest version is 8. Many of us not running 8. Many of us are running some 7 or 6 or God knows what. But 6 may there is some bug, right? Now how do I go to 6 and then that release is over some 5 years or 2 years, 3 years ago. How do I now make a fix, some new major security fix, we have to update a patch to 6. There will obviously be people who are using version 6 for whatever reason. So if I am able to have a version control system, I can say, okay, get me the release 6, make a fix to that, build that, ship that. So I now have the ability, because I can go back in time, to get files at a different point in time, make changes and fix software. So how does it work? Underneath the covers, obviously every version control system has a different way of doing it. But the analogy that you should keep in mind when you are working with the tool is, imagine you are playing a game. Many of you must have played some video game or the other. When you play a game, you know that many smart, good gamers will not play from level 1 to level 10 in one day. We don't have that kind of time. And even if you do, sometimes it's not easy to do. So many games will have, what's this, save. You save the game. So I finished level 1. At the end, before I meet that monster, I save the game. Because I don't want to finish all of level 1 and then fight the monster. So what you do is, you play the game, you achieve at a point that you are happy, you make a save. Then next time you want to start, what do? You start from where you saved, not from 0. Correct? So you are playing a game with 10 levels. You don't, last fellow is very difficult. You don't start from level 1 all the way to level 10. So you save just before you finish 10. And then you say, okay, now I will fight the monster and I win. Right? So it's a very sensible way of working. The analogy is almost direct. Whenever you create your source code repository, you are happy with it at some particular point of time, you tell the version control system saying, these are files, these are the files, this is a working set of files that works for me. And you add a message to it and you make what's called a commit. When you do this, the version control system knows that, hey, at this point of time, these are the set of files. So if somebody else wants the set of files at this point of time, they can get it. And it will associate with that particular point of time a bunch of additional metadata, like a log message, a revision number, and any other data you may want to associate. So there's something called a change set. If you look at HG, we look at it. So it will give all of that information. So you are able to identify exactly the set. Okay, so let's now move on to actually getting something useful done. The tool we are using is called Mercurial. Many of you would have heard of various other tools. So there are two classes of tools. There is the old class and the new class. These are not quite there in the slides, but I'll just tell you some history and background. Original version control systems are what are called the classic version control systems. Examples of these are like CVS, concurrent version system, or SVN, which is subversion. There are a variety of others, but these are probably the most popular. This was about 5 to 6, maybe even 10 years ago. But today, actually even 5 years ago, subversion was used a lot. And these tools required access to a server, in the sense that if I were to use a repository, the repository was one repository that was available in a central location, and everybody had to send their changes. So if you imagine I am the central repository, every one of you is sending me files, all of you will need network connectivity to me, right? However, this is a problem. For many of us, network connectivity is a problem. Secondly, everybody needs access to the server, which means if the server goes down, finished. Nobody can do any check-ins. Nobody can actually make any connections to it, and therefore they cannot actually commit their changes, or they cannot log their changes. So after a while of development, distributed version control systems came about. There were many of them, but probably the two most popular or three most popular distributed version control systems today are Git, which you must have all heard about, which is what the Linux kernel uses, Mercurial, there's also Bazaar, and there are a whole host of others. There's like old ones like Monotone, Darks, there are a variety of other version control tools, distributed version control tools. In distributed version control tools, the idea is that everybody's repository is their own. There is no central one repository, but everybody has their own copy of the entire repository, which makes it extremely convenient. Okay? Because now I don't care about a server. I can be on an airplane without any internet connection whatsoever and continue to do my work on my laptop. Okay? It also allows for a lot of very easy development by multiple people spread all over the world who then later collaborate. Okay, so the modern tools are distributed version controls, and HG is one of them, Mercurial is one of them. So we are using it because it's easy to learn and use. We could have also used Git. Please note that there are some things that may be different if you were to use Git, but the essential ideas are the same. And if you go and read some little documentation after this course, you will have enough initiation to understand, oh, this is how Git also is supposed to work, and it's not very different. So basically it's very easy to learn and use, as you will see. It's lightweight, and I'll show you how lightweight it is. Once you install Mercurial, it's trivial almost to create a new repository. It doesn't require a server, it doesn't require any special kind of Apache server, or it doesn't require special configuration. You have a directory, you can use it as a repository, essentially. It scales very well. Things like the Linux kernel, Mozilla project, all of these large projects actually use distributed version control systems today. Mercurial itself is written in Python, and so it is also extensible in Python, which is an interesting feature. So how do you install Mercurial? I think all of you should have it installed already. Okay, so let's proceed. With respect to installation, if you are on a Debian or Debian-like system, I think you have to do sudo apt get install Mercurial. Tortoise HG is a Windows client, so there are a variety of options for installation. Depending on if you are a Red Hat machine, it will be something different. So if you are using the live DVD, it should have HG installed already. So essentially, once you install Mercurial, this executable called HG will now be available for you. So let's now try a little example. So I am in /tmp. I hope the font is visible. Is the font okay? Big enough? Little bigger? Okay. So I am in /temp. I now type HG. The command works. So it says Mercurial distributed SEM. HG version. Let me clear. HG version tells me this is the distributed. This is the Mercurial distributed SEM. Copyright, blah blah blah. Okay, and please note it's free software. And the version I am using is 1.4.3. Depending on the version, certain features may be slightly different. So don't worry about it right now. If you have it installed, that's all you're going to need right now. So now let's begin with creating our first repository. What is a repository? So a repository is basically the place where all of your files associated with a particular project exist. Okay. So essentially it's all your project files along with one special directory that is made depending on the version control tool you use, and this directory stores all of the changes. Okay, I'll show you the details of this. The key idea with version control systems is every time you make a check-in or you make a change or you tell the version control system, I'll tell you these when you make a commit, this term commit will come again and again and again. Essentially, I have a set of files. When I commit these set of files, the version control system understands that these committed files represent the state of this repository at this point in time. So think of it as, imagine the classroom. I have some students. If I want to take an instantaneous snapshot of this classroom, I'll take a photograph. Now I have that photograph saved, so I know where every student is sitting. One day later, students have changed positions. I want to record this. So I take another photograph and I get another picture. A commit is like that. I have kind of like a picture, but in this case that's only a picture, it's only an analogy. But in the version control system, I can actually get all the students back at that particular point of time. Okay, I know everybody is there, this was their state, all of that information is now available to me in the repository. So this is what commit means. So what happens when you do a commit is the entire repository is kind of snapshotted. So I know that at this point of time, this is the state of the full project. It's not just the state of one file. One file also is available because I know the full repository. The advantage this makes is, supposing I am building something like Firefox, the one file does not exist in isolation, it exists along with a bunch of others. So if I make that change, I know that every other file is also linked to that point. So it helps me keep track of that. So I'll repeat, a repository is the directory which contains all of your files. It will have one special directory typically called .hg, which is hidden, which will contain all of the changes. And whenever you make a commit, you are essentially snapshotting the entire repository at that point of time. So let's make our first repository. So let's just I'm going to create a dummy directory, my project. So now I'm inside this my project. Fine. This project does not have to necessarily be empty. So it could have some dummy file. So I'll just create one dummy file. Since you have done bash, I'll write a little bash script. So I have my little hello world bash script. I have one file in this hello.sh. I am in /temp/my project. So now how do I create a new repository? I simply type hg init. That's it. I have now created a repository. So where is the repository? Notice that there is this new directory here called .hg. There is hello.sh and there is .hg. Let us look at what .hg contains. Some change log requires some store. So it has internal data that is none of our business to touch. So do not delete the .hg directory. Do not make changes to it yourself unless you know what you are doing. Okay. So basically this .hg directory is this magic directory that keeps log of all the changes made henceforth to this repository. Okay. Please note that if I go out of this directory, there is no repository. It's only in my project that this exists. And inside my project, everything can be tracked. I can make subdirectories, subdirectories, all of that can be taken care of. Okay. So I'll repeat, hg space init will create a new repository. It creates a .hg directory, your working directory, and this .hg directory you should not touch. Okay, it's a secret directory. So now, first thing is we need to learn how to use the tool more effectively. There are always man pages, but one very useful command is hg status, which will tell us the status of our repository. Okay, and we will be using it a lot in this. So get comfortable using hg status. The second thing that you should learn is how to use hg's help system. So if I say hg help some command or just hg help, it will show me information. If I want to scroll it, I pipe it to less, it will tell me list of available commands. Okay. So the left hand side column here indicates the command name. This is a short description. If you look at hg help command, so let's look at add hg help add pipe to less. So it tells me that the option is hg add some option, some files, both of which are optional, and then it gives me a description of the feature of the command and the various options that are applicable to that command. So it says -i, -x, -n, so on and so forth. Okay. So recapping, hg init creates the repository. Hg status allows you to see the status of the repository at this time, and hg help gives you help. So I'll give you a minute. Okay, so you want me to go slow for terminal sessions? Okay, I will do that. Thank you for your feedback. Anyway, I've repeated myself enough this session. So I now want you to experiment. I will give you 2 minutes. It's now 10:47. When do we break? 11. Okay, fine. So 2 minutes I'll give you. By 10:50 I will resume. I want you to do the things that I have done. Number 1, make a directory in /temp or anywhere you want where you have write access. Call it whatever you want. This my project that I have used is just the name that I have picked. You can use any name you want. Any valid directory will work. Okay. So there is no sanctity to my project. Call it anything you want. CD into that directory. Use hg init. Type hg help. Type hg status. And be comfortable with using all of these commands. I'll give you 2 minutes. I hope all of you are doing this because it's very important you actually do it now. Because at the end of the session, there will be 10 different commands, and if you have not done the first few, you will be stuck in the subsequent ones. It's important you know how to do this first. Okay, so we are done with the time. I am going to proceed. And no one has any questions. I think I have repeated myself enough that it's clear to everyone. Anyways, the test will reveal whether it has been clear or not. So I will repeat again. HG init creates a .hg directory which has your entire repository. HG status will give you status information. I will explain the details of the HG status command shortly. HG help will give you information about the command. Yes? Yes, you had a question?
As you said that Mercurial is local and we don't need servers to actually connect to repositories.
Yes.
But we have a Unix utility called RCS. That's also local and that can be used as we use the Mercurial.
I'm sorry?
Can you actually elaborate on the advantage of using Mercurial over RCS?
Over RCS? Are you talking of revision control system, the original RCS tool?
Yeah.
Okay.
Because RCS can be used as we use Mercurial.
Yes, well, but RCS is file centric, it's not repository centric.
So that's also local. We don't need a server repository to connect to.
But RCS is like, it's like asking it's like a dinosaur as far as we are concerned. RCS does not allow you to serve your files. RCS is file centric, it is not repository centric. So let me explain. The question is, RCS is also a tool that you can use locally, does not require a server. It's a very valid point, it's a very valid question. HG is also local, but remember that they are completely different beasts. If you have used RCS, it will actually create the revisioned file in the same directory with one special file name. RCS is file centric, which means for every file, you will have to do the revisioning yourself for every file, which means it only is file centric. It's not entire directory or entire project centric. HG is project centric. I make a commit, it reflects the state of the entire repository. RCS also typically gets in your way. I have used RCS before. It's a clunkier tool. It's a lot more old-fashioned tool, but it's very convenient if you have one single file that you're trying to revision control. The other thing with RCS is it doesn't have all the other nice features that HG offers. It's very difficult to collaborate. I can't start a server for HG, for RCS trivially. Well, you'll have to build a separate server. HG comes built in with it. There are no models by which I can clone that easily. Its merge model is non-existent. You have to basically use patches and merge it. Whereas here there's a notion of merges, and if you start using Git, there's the notion of pull requests. There's a lot more involved with HG and Git and the other modern tools that RCS is even worse than CVS basically. If you're talking of a serious project, people will not even consider using RCS for a project, for a single project, let alone a distributed version control project. So it's basically not even a fair comparison. Does that answer your question? So the .hg is simply a directory. Think of it as a magic directory and that you don't have to worry about its contents. Don't touch the directory, don't remove it, and don't touch anything inside that. That is the directory which contains all of the revision control information of your entire repository and the configuration. A bunch of things are stored in .hg that you don't have to worry about. So don't worry about it, it's just a directory. Okay, are we all clear? No, I'll finish a little more after this. Okay, so I'll just do one more little concept. I'll just do one more important thing. It'll just take 5 minutes. Is to discuss status codes and the HG status. So notice that if I do HG status, it prints out this peculiar line saying ? hello.sh. What HG is telling us is, I don't know anything about this file hello.sh. Now, instead of this question mark, you can have a variety of other codes. They are called status codes. There is capital M, capital A, R, C, exclamation mark, question mark, and I. Each of these means something different. What you are seeing now is not tracked. It means this hello.sh, hg is not tracking. You have not told it to track it. Hg is not magic. It cannot read your mind. What it will do is what you tell it to do. So you have to tell it, hg, pay attention to this file. Then it will start keeping track of it. Okay. Once you have told it, hey, these are my files, then it will tell you, oh, this file was modified. Oh, this file was added. Oh, somebody removed this file. Okay. Oh, this file has a conflict and you have to manage that conflict. C typically means you have to clean up this file. It's a mess. Something happened. Somebody else made something, you made something, they are now conflicting. You have to fix. Exclamation mark means that file is missing. That file you deleted. It's missing. You didn't tell me you are going to remove a file. If you tell hg saying remove this file, he will say, okay, I won't bother you. But if you remove it behind hg's back, he will say, array, this file is gone. So hg keeps track of what files are there. You have to tell it, keep track of these files. So until you do that, it will say, I don't know anything about this file. It will give you a question mark. Okay. So for example, if I touch another file, it says test.sh also I don't know anything about. Now if I remove test.sh, it won't say anything because it doesn't know anything about it. It won't say, oh, that file was removed. Until I actually tell it, this file was, you take this file, add this file, it will not bother about that file. Okay. Final tag is ignored. So you can tell hg, ignore all out, like a.out. I want to ignore all the .out files. I don't want unnecessarily have it showing me question mark. So you can tell it to ignore. In which case, sometimes if you say hg status verbose, it will say these files were explicitly ignored and then it will show you I. Okay. So basically, the status codes are explained here and question mark currently tell us that the file is not added. In the next session, we will start looking at how to add files and how to commit files. I will do that in the next session. There are some questions that I will answer. First question is it always needed to create the .hg directory? The answer is no. When you do hg init, so you should never create .hg yourself. When you do hg init, it will create it for you. You don't bother about it. As I said, don't worry about the .hg. As far as you are concerned, it doesn't exist. Leave it. Don't think about it. Okay. So .hg will be created. When I run hg init, it will create the .hg directory to the current directory that you have added. When wherever you did the init, that directory it will add it. And that directory is the root inside which all files will be tracked. Okay, so I will repeat myself to end this session. Hg init, we motivated the need for a mercurial system, showed you how to create a repository, how to find the status, how to get help. Technically, this is all I should be able to, if I teach you this, you should be on your own, but obviously in the next sessions we will look at more details. I also elaborated about status codes, explaining to you that question mark when you do hg status means that the file is not being tracked. In the next session, we will see how to add files, how to make changes, how to track these changes. Okay, so there is one more question. We have to install Mercurial, due to which we are using hg command. If we change the software, naturally. Hg is a software like any other software. It's like your bash or sh, which is why I covered installation at first. In case you were not paying attention, I said very clearly that hg needs to be installed. You can install it on a Debian system like this. Tortoise hg is available on, I think, Windows and Linux as well. These tools will give you the hg command tool that you can use, that we have been using so far. So if you are using git, obviously the command you will use is not hg, it will be git or whatever git installs for you. Okay, but we are using hg for the purposes of this course. Remember that there will always be differences, so do read some documentation before you switch to some other version control tool. Just because you know hg doesn't mean you know everything about git. There will be some differences, some subtle differences, but the overall structure, the strategy, the workflow will be kind of similar, will be very similar. So if you understand one and are comfortable using one, switching to another is not very hard. I will just quickly repeat what we did the first part very quickly. The idea is we are creating a repository, and this repository will contain all of our files which we want to be properly managed. As a result, we need to create this repository. So the way you do that is to first do hg init, and the hg command is something that should be available. You should basically install Mercurial, and the way to install it depends on your platform, so we won't get into the details, but most of you should have it installed. So if you go to the shell and create a directory, I have created my project, so let me create one more. So I have created this new folder called junk. I cd into the directory called junk, and here I do hg init. That's all it takes to create. And ls-a reveals an empty directory with a .hg. Okay. The next command that we looked at was hg status, and right now status tells me nothing. I created a simple shell script. I will copy that shell script. Now we have hello.sh in this folder, and now hg status tells us there is some file called hello.sh with a question mark, the status code for which were discussed in the subsequent slide, saying it is not tracked, this file is not tracked. The other command that we mentioned was help. So hg help will give me a lot of information, but if I want to say hg help add, it will give me specific information. If I want to pipe it through a pager, I do hg help add pipe to less. I'll repeat that. That is the command I am talking about, hg help add. This will give me information on the add command with all the details. So basically, when we do hg status, it will let us know whether the file is tracked or not tracked. In this case, the file was not tracked. One important thing to note is it is perfectly fine to do rm minus rf junk, except your whole directory is gone and your repository is gone. You lost everything. So that directory where you have your code and the .hg directory, if you delete, you have no help. Your repository is basically gone. Okay, so but remember that I had two repositories. I have my project. I don't want the junk anymore, so I am going to remove it. Okay. So basically, it is just another directory. My project, of course, is still a repository, and it still has the file. Okay. I just created the point I was trying to illustrate is it is trivial to create a new repository. It doesn't require anything. You just need to do hg init. Okay. You can create them, you can destroy them. It is yours to do as you please with it. Now, obviously, if you want to keep it safe, it is your responsibility to keep it safe. So you want to back it up, you tar it up and put it somewhere, save it somewhere. If better yet would be if you're going to share this on a long-term basis and it's an open source project, you use any well-known site. There's something called Bitbucket, which lets you host hg repositories on the web. Or you can use code.google.com. Again, they have Mercurial hosting that they provide for free for open source projects. So if you have an open source project, you can always use those to host, in which case you can even delete your own repository. It would still be saved upstream wherever you are hosting. Okay, so this is what we covered. I did it at length, I have just shortened it. When you do hg status, remember that the first column gives you a question mark, the second column gives you the file, I showed an example where I had two files. So if I do touch test.sh, now it shows me two files that it has no idea about. Both files are not tracked. Once I tell, the thing about Hedgie is you have to tell it what files you want it to track. If you tell it to not track something, it is not going to bother about it. But if you tell it to modify something, if you have told it something, then it will make sure that it tells you, oh, this file is modified, this file is removed, or this file is added, so on and so forth. It will tell you only when you tell it to track a particular file, or if you tell it to ignore a particular file. So our next task is, so let me first remove this test.sh was just a sample. I am going to remove it. So if I do rm test.sh, please note that Hedgie is not going to complain if I do Hedgie status. It is simply going to say hello.sh is not known. Because I have not told it about test.sh, it is not going to give me warning, nothing. As far as Hedgie is concerned, that file does not exist, essentially is all it's saying. So how do we now tell Hedgie about these files? So from Hedgie status we know that none of the files were tracked. What we need to do is we need to do Hedgie add. So let us do that. Hedgie add hello.sh. Okay. So Hedgie add specific file name. I hit enter. No problems, no errors, which means it went well. And now if I do Hedgie status, what do you expect to see? You will see question mark has become A, which means this file was just added to the repository now. However, all you have told is there is this new file which has been added to the repository. You have not actually said, you have not taken that photograph. Remember I gave you the analogy, if I have a classroom, I want to know the state of this class at this time, I take a photograph. We have not done that yet. All the Hedgie knows is that file has been added. Okay. Now I have to tell Hedgie to say, okay, I finished adding all my files, take a snapshot, save it. Okay. How do we do that? What we need to do is, we need to say Hedgie commit. So Hedgie commit. If I simply hit return now, it will tell me you have not supplied a username for this particular user who is using Hedgie. And it says see Hedgie help config. Okay. So essentially, every time I make a commit, I have to tell it who I am. Then it will know, oh, so and so made this change. The idea is, if you are sharing with repositories with other people, you know which person has made which change at what time. So you need to supply a username. So let's see, Hedgie help commit. Commit changes to the given file, to the given set of files. Notice that it has a -u given as the username. Okay. And the format is as described in the slide. You say -u, first name, last name, email. So let's do that. Hedgie commit -u. Okay. Okay. So now it is asking me to use a editor to edit the commit logs. I am going to choose Vim, which is 4. Over here, I basically have an editor window, Vim in this case, and I can add a log. I can say now this is a very silly message. Normally you will give a more meaningful commit log. Remember that this commit log will be stored with this change set. So you know, hey, I have done this. Okay. So if you made a bug fix it's a good idea to describe the bug fix, say point it to a URL saying okay, there's a bug fix here, so this patch whatever you want to write. Okay, it's good to keep your commit logs reasonably informative. This does not mean you should write a Ramayana here. The idea is you write something small, descriptive, that gives you a sense of what has happened. Now you simply save it. The lines below this, all of these lines will not be added. All these hedgy fellows are just information for us to know that what it says is help message here, enter commit message. User, it's telling me that this is the user who's making the change, and here it is saying it is added hello.sh. These are also, if I added 5 files, those 5 files will be listed here so that you know what files are being changed. Is this clear? Now I save this. Now if I do hedgy status, it says nothing. Okay. Remember, last time when I did hedgy status, it said question mark. There is no question mark. Now it knows that hello.sh is there, and the current version of hello.sh is the version that was checked in. There is nothing, there is no change. So hedgy is saying everything is fine. ls, it still has hello.sh. So if I do sh, it gives me hello world. So everything is fine now. So hedgy is happy. Hedgy status gives us information that everything is fine. Is this okay? So I'll repeat what we've done. We first did hedgy status. We had one file hello.sh which it said is untracked. And now we said hedgy add, it added that file. At which point the status said question mark has become A. Then we committed, we said okay, I finished adding all my files. So imagine I had put one file, add it, put another file, add that, third file, add that. Now I have a set of files. Now I can say hedgy commit. It means hedgy will now save at this point of time, these 3 were the files that were added to this repository. So I did hedgy commit. It gave me an error saying you have not set the username. So to fix that, I first did hedgy commit. It gave me an error. I looked at the help and found that the option is I have to give hedgy commit minus u, this full name. Correct? Then it opened an editor inside which I was able to give a message saying something, additional files added, this fixes some bug, whatever message I want to associate with this change, with these set of changes from the last time I committed. I continue to commit. Okay. Once I do that, if I now run hedgy status, it says everything is fine and the file is there. So now hedgy is aware of the file and I have snapshotted the system at this point. Now I want to see what has all happened in the repository. What I can do is I can say hedgy log. Let's see what it gives us. So it says hedgy log says change set, some funny looking thing. Tag is some, again let's forget about the tag. It gives me my username Prabhu Ramachandran, prabhu@fossee.in, the date, that is the time at which that commit, last commit was made, and the summary. And notice that it's only given me the first line. Okay, so if I did hedgy log minus v, it will give me a verbose log which will tell me the entire log string that I have supplied. Okay, so it says adding out, so I made a typo, adding our first files, this change fixes issue number blah blah blah, whatever. So whatever I have typed there is now available. So 1 year from now, if I come back to this directory, if I do log, I know that the first commit, this is what I did. So it therefore makes sense to have clean log messages, meaningful log messages. So later on you have to understand what these things are. So the first terminology we are learning here is, what is this change set? So a change set, this is a definition, so I will repeat exactly what the slide says, is an atomic collection of changes to the files between successive commits. Okay. So if I make another commit now, the change set basically records all of the set of changes between the previous commit to the current commit. Okay. And it has a number that you see here. The first number is the revision number, the 0 you see here. The second is called a change set ID, which is not of too much relevance to you. So you don't have to remember this too much. You can use the revision number for all practical purposes in this case. Okay. The 0 is the important identifier you should keep in mind. And as we've seen, the log information gives us change set, the identifier, the user, the date, and the summary for this particular change set. Okay. Now let me do this again. Let me create another file. Okay, simple file. Now I have hello.sh and test.sh. What should I do now? HG status. Now it says test.sh, I don't know anything about it. So what do we do now? We add this file, we say HG add test.sh. Now HG status gives us what? Test.sh. What should HG log give me now? HG log will list all of the commits, not the adds. So HG log will still only tell me 0. Okay. I will repeat what I did. I created a file, okay, vim test.sh. I added the file, looked at the status and the log. Now I have to commit, HG commit. So I am going to use the previous commit. So I can do this HG commit blah blah blah. Instead of going into an editor, if I just have a single line, I can always type -m and give the commit log also in this one line. Supposing it's just a one line. The -m will allow me to give the commit message in the same that command, rather than it open a separate editor. However, I always prefer using the editor because then I can write a nice log message. But if sometimes for a single commit, you can just do -m. To go slow, okay. Why is it asking me? So let me edit this. Now it has added the file. I will repeat what I did. Not clear why it is not doing this for me. I'll repeat exactly what I did. I first created this test.sh. So I did vim test.sh. I created this file. Then I did hedgy add test.sh to add the file. It got added. Then I did hedgy commit -u blah 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 -m some message. Okay, and it was committed. Now if I do hedgy status, again it shows me nothing. Means all the files are tracked. Now if I look at hedgy log, it shows me two things: adding out first files and adding test.sh. Is this clear? So the first one is 1. This is the first, this is the current latest version. This is the original version that we had. Is this clear? So I am repeating myself many times, so if you miss something once, you will get the hang of it. Don't worry about, if you just generally get the idea, don't worry about it. So now we have saved 2 versions of our project. Okay. Now there is one small problem. Every time it is irritating to say hedgy commit -u blah 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 blah, and I have to write my full name, and I have a long name. So it's not very convenient to be able to do this every time. I have to keep typing my name, my email address. So there is a file called, in your home directory, .hedgyrc is a file where we can add our username permanently. Okay, so let's do that. To do this, I am going to edit ~.hedgyrc. Okay, over here I will say add a UI section. So I am saying in the UI section, that is the user interface, my user name is Prabhu Ramachandran with my email address. I made a mistake here. Okay, so create your own file with your own user details. Now I am closing this file. Has this information. I will give you a second to write your own, I'll give you 10 seconds so you can write your own file. Okay, so I assume you have looked at that carefully enough that you understand what is going on. Now if I want to make a fresh commit, I don't have to supply this -u every time. So what is with this commit? What are these commits and how do we utilize these things? Well, every commit is atomic, which means it's one unit. It's an indivisible thing. Something that's atomic means it's indivisible. I can't break it down any further. A commit is one unit of changes. Okay, so atomic changes, for every set of changes that you think is one concrete unit, you make a fresh commit. You typically give a single line summary. The first line should be a single line summary. Remember, when you do hedgy log, it only prints the first line. It doesn't print the whole line. Remember. Okay, as an example, if you look at hedgy log, so let me, since I made the same mistake, you should not make the same mistake. You should not have a space there. I unnecessarily indented it, that's why there was an error. It should look like this. username is aligned at the left. Now if you look at the log messages, notice on the second line it basically says it has truncated the log message, and I had to do log space minus v to get the full message. So a good idea is for you to make sure that you have a single line summary, and then subsequent lines you have an elaboration if you need an elaboration. So if it's a trivial commit, you don't have to write more. If it requires more detail, you supply the detail in the next paragraph. Okay, so you can say the next paragraph, why the change, what does it affect, known bugs, all of that you can specify in whatever detail you want to do. And it's a good idea to have this detail because then you will be able to use that detail later on. So someone has a question about no HGRC file in home directory. Well, you have to add one. There is no .hgrc in your home directory, but you will have to create one, as I did. I clearly showed you that you vim that file, save it, and then you created that file. Only then will you be able to use, you don't have to supply the minus u. If not, every time you make a commit, you will have to do with the minus u. So let's make one more edit. Now let's move on and make a change. Firstly, what is our current status? HG status says nothing, which means everything is fine. All the files are intact as against the last version. They are all at the latest version. There is no problem. So now let me edit a file. So now I don't like this white space, and I will capitalize this. And I will put a punctuation mark at the end. This is my new version. Now notice that the file now says, the status is clearly saying, M you see in the first column clearly indicates that, so if you go back to the slides, M means modified. So what it's saying is, the file hello.sh alone has been modified, test.sh has not been modified. Now if I want to save this, now I can continue to make changes that I want, but if I want to tell HG saying, okay, I am done, record this current change, what should I do? If I want to tell HG that this is my current state of directories that I am happy with, I have to do commit. So I do HG commit. Notice that in this time it didn't give me any error because I have set the username already, and it has filled that out for me. So now I can add the summary line. Okay, so now I have given a detailed error message, log message saying summary is better hello message, details are there were punctuation and case problems in the previous version. And now I save, quit, commit is done, HG status empty, which means now it is recorded. Now if I say HG log, it tells me that the latest is better hello message, previous one is test.sh, and the last is the original commit. The first commit is adding files that are initial commit. So all these three versions are now recorded fully. Now if I want to add more files, I can continue to do that. I want to add a directory, add a file, I can continue to do that very easily with this system. With the same strategy, you add the file, commit, add, commit. You want to remove something, we will look at that in a short while. Okay, so some questions people are asking. If more than one file is in the directory, is there any provision to distinguish by name in the log? Distinguish what by name in the log? Your commit message applies as a whole to all files. If you want to distinguish between each file change, you have to explicitly only commit those files or add those files. Okay. So for example, if you do hg help commit, you can say commit either a specified file. So if I want to say I don't want to commit all the other changes, I want to only commit 3, 4, this file hello. I don't want to commit test.sh, even though there are changes, it's modified. You say hg commit hello, and only hello will be committed. So you can do things like that. However, you can't distinguish between the files once you make the commit. The commit as a whole records changes to all of the files. The second question is, I typed hg minus u, your formatting of the string is wrong, and it's not hg minus u. You have to give it as hg some command minus u, and I am not sure why you are getting a waiting for the lock on working directory. Something you must probably have done a previous commit that is broken, that is not completed. And someone wants me to repeat the vim.hgrc. Okay, so I will just cat the file. I'll clear the screen. This is how the file should look. Bracket, square bracket open, UI, close square bracket, username equals username and email.